It was a calm Sunday for users of 3D printers. Everyone was printing with their standard printers, at standard speeds and in standard quality, and they seemed happy. But suddenly a brand came out of nowhere. It ruined the peace of both other 3D printer manufacturers and those who use these printers. It totally flipped the market. You asked me about it a lot. You wanted it to be examined. I always ask myself this question too. What the hell is this BambuLab? Come on, let's check it out together. Let's begin. BambuLab has become one of the brands frequently mentioned by 3D printing users and those interested in this technology. I actually hear its name so much that it feels like it's been in the industry for years, but indeed it's not like that. BambuLab was established back in 2020 by engineers who are deeply experienced in robotics, artificial intelligence, material science, and the internet. They worked on the X1 series for 2 years, and then introduced it to the public as a Kickstarter project. In a very short time, the desired fund was collected with the participation of more than 5,500 people, and users got their printers in 2022. The brand had already made a quick entry into the market, and then in the same year, when X1 Carbon was listed among Time magazine's best inventions of the year, they perhaps became one of the world's most popular 3D printing brands, even beyond their own expectations. Let's start reviewing the design and features of the printer right away. Then I will both show you the printings I received and share my experiences during this process. BambuLab X1 Carbon is one of the most minimalist designed compact printers I've ever seen. Its matte aluminum body, with its darkened top and front windows, has an extremely elegant appearance. The dimensions of the printer, which can be positioned almost anywhere in your home, 38.9 by 45.7 centimeters. The X1 Carbon has a 5-inch color touchscreen display with a resolution of 1280x720p. The printer's screen is very easy to use thanks to its simple interface. When we open the front cover and look inside the printer, we see an interior design where space is used very efficiently. A flexible build plate was used for printing tasks. The maximum printing area we can achieve on this plate, interestingly, is 256 cubic millimeter. Build plate is movement on the Z-axis with 1 trapezoidal screw at the back, 2 in front, and 2 steel shafts. There's a motor at the back of this system transferred to the front shafts via movement belts. Thus, movements become more stable and the plate vibration effects also decrease. Leveling is done completely automatically with precise double control. The nozzle touches the build plate from many points and accurately detects the correct level with the pressure sensors located beneath the plate. At the same time, the LiDAR sensor integrated into the printing head also continuously controls this level with 7-micron precision. The LiDAR sensor's job isn't just this, it controls material flow before printing and lets the printer calibrate itself based on this data. If desired, it can also check whether the first layer of your printing is properly laid out or not. The Y-axis movement of the X1 Carbon with a core XY system is provided by steel shafts, while the movement of the printing head also takes place on the carbon shafts. Thanks to this light and durable material, especially in sudden y-axis movements, movement actually becomes easier and vibration effects are reduced. Another nice feature is that carbon mills do not require lubrication. The printer boasts a full metal dual-gear extruder system and can provide a maximum material flow of 32 mm3 per second. Thanks to this extruder and system, the X1 Carbon can achieve a speed of 500 mm per second with an acceleration of 20,000 mm per second squared. High speeds especially require very good cooling in materials like PLA. In X1 Carbon, for this, there is a quite large 12-watt auxiliary fan in addition to the cooling fan in the printing head. Thanks to this powerful cooling, problems such as stringing or sagging can be prevented. In addition to the cooling fans, there is also a case ventilation fan in the back. Bambu has also added an active carbon filter to this fan and aims to prevent the spread of smell when working with odor-causing materials like ABS. The printer has wireless connectivity. Thanks to this, you can connect with your printer via your computer, phone, or tablet, send printing, start and stop the printing, or make instant interventions to some basic printing settings. Also, the camera on it lets you watch the printing in real time and you can shoot time-lapse videos with this camera. The only feature of the camera that can shoot in full HD resolution is not just image capture. Thanks to this camera equipped with artificial intelligence, it warns the user if there is a problem with the printing or if there is an issue with the position of the build table. X1 Carbon can achieve multicolored prints with AMS, the automatic material system. With a single AMS, you can use 4 filaments in the same printing. By increasing the number of AMS to 4, you can use a total of 16 filaments in the same printing and create multicolored printings. In fact, if you also use bamboo filaments, AMS automatically detects which filament you have installed and makes the ideal settings for printing itself. There are even areas within the automatic material system where moisture-absorbing silica cells can be placed for longer storage of filaments. When we see BambuLab X1 Carbon, we can tell it's a 3D printer with great features. What matters is the advantages these features provide. I also used the printer for a long time. I worked on materials like PLA, ABS, ASA, PETG, TPU. I did speed tests. Let's take a look at the printings I got with PLA right away and start reviewing the models. The first printing is the classic test model, the Benchy boat. I find no fault in this printing that I took at speeds of 400, 500 mm per second. There is a completely smooth surface. There is no sagging in the front part of the boat making a right angle or in the door windows that are printed without support. There was no threading on the model. It performed the cooling task quite effectively. The second model is a filament hanger that can be utilized on the printer. I got this with the standard settings in Bambu Studio. Standard settings vary between 200, 300 mm per second. This is a very good result for a printing taken at this speed. Of course, it wasn't a difficult model, but still the result turned out quite successful. After 2 small printings, I wanted to work on large printings right away. The bookshelf decor or book holder you see consists of 3 parts. It looks like ancient Greek temples. You can place it wherever you want by inserting books in between, and I think it can create quite a nice view. Again, I got these printings at Bambu Studio's standard 200, 300 mm per second speeds. All 3 models turned out quite nice. The layers appear smooth. I can say it is a model that is prone to stringing because there are areas like the columns behind that middle part as well as in the front with parts rising separately from each other. But there's no hint of stringing. There are still the 90-degree right angles, so the parts where the printer builds bridges. Again, we can see these parts between the columns and right behind them. There hasn't been the slightest sagging. The only point that can be said as a flaw on the model is the highest point of the arch in the middle. It's quite normal to have a slight warping in this type of printing taken without any support. I'm not saying this is a printing error per se. I just wanted to show you it can also be easily cleaned up. Of course, when you have a carbon combo with AMS at your fingertips, you immediately want to switch to colorful printings. It was a system I was very curious about, and I had question marks in my mind about this system because I have been using a 3D printer for many years. There may be times when you have difficulty changing the filament even by hand. It gets stuck in the filament sensor, or you cannot engage the extruder's gear while pushing the filament. It actually bothers me a little sometimes. Now I said, will AMS do this? Occasionally a printing hundreds of times, and will it do it without any errors? And I took a printing with AMS for exactly 83 hours. The New Year approaches with more models featuring New Year themes like snowman and Santa Claus figures. It's printed in one piece, but it has movable parts. Both seem to have a texture as if they were hand-knitted. I don't see an issue that I could indeed call a printing error or an AMS error on the snowman. There are stains formed at a very few points, probably due to the nozzle tip not being completely cleaned. I can see them right under your nose or on a tiny spot on your scarf. These are usually spots caused by black filament. Aside from these, the printing is flawless. Despite changing the filament 399 times in this printing, not even the slightest line has formed between the layers. Santa Claus is the same. A total of 509 filament changes occurred while printing this model, and it left no layer marks on the model. Again, there is a small black spot right on his beard. Apart from that, no other flaws are visible. The thin, detailed weave textures also came out very clearly and successfully. Of course, AMS is not a fast system. I mean, for example, this Santa Claus printing took 15 hours. I'm sure you were surprised by this duration. I was also surprised when I first saw it, but it's true. The more color changes there are on the model, the longer it takes. Because the head is doing the printing, then it first finds a 0 point, then it comes to the part where it will change the filament in the back. It's heating the head more, it's retracting the current filament, then pushes the filament, it'll load so the color change occurs. Then, he thoroughly cleans the nozzle tip. It goes and first conducts a printing in the test tower on the side. And then it continues with the printing of the model. It also takes time to perform these operations. On such a printing, it did this almost 3 to 4 times on every single layer. This also caused the duration to extend. Think about it. The model has 201 layers, but 509 filament changes. For instance, if I made this printing in one color instead of multicolored, the printing time would be only 2.5 hours. So we can say that AMS has extended the printing time on this model by 6 times. I want to show this example to explain its logic fully. It's a bolt measuring device. 3 colors were used in printing. Just change the filament several times and this model printed in 45 minutes. Without the color change, it might have taken 40 minutes. So when the change is small, the difference in printing time is also small. As for the printing quality, there's nothing negative to say. The layers look quite nice. The top surfaces and the numbers are very clear. There's no such thing as a nozzle trace. And indeed, the longest AMS test printing, it took more than 2 days, a full 50-hour printing. I thought I definitely had to take such a long print to measure the reliability of the system. You see a mask model, 4-color printing. The surface quality is as successful as in previous small models. Despite changing the filament 1381 times in a span of 50 hours, there is neither a single layer line nor any other noticeable printing error whatsoever. Despite being printed at speeds of 200-300 millimeters per second, there's no vibration effect. There are still black filament traces at 1 or 2 points. This is due to the difficulty of switching to color after black filament. If you pay attention, other colors don't mix at all. It's a print taken without support with a bit of sagging at steep points. But as I mentioned, this is normal because no support was used. Generally, I have to say it was a good printing and the AMS system performed well. Frankly, I was surprised. I didn't expect to be able to print this smoothly. I thought there would be a problem or two somewhere, but it didn't happen. In these specific printings, which only last a mere few days, parts that ideally should fall into a few designated filament boxes in each model were instead attached to the nozzle and fell into the printer or got stuck in the color change tower that was meticulously printed after changing the filament. It could have created a problem, but it didn't. So I can say that the only issue I could mention as a fault within the system is this. Sorry, but much filament is used for color shifts. For instance, this mask model weighs 245 grams. To produce this in color, an extra 617 grams of filament were used during filament changes. It consumes a lot of filament for color change. But as mentioned, this is not something that will occur in every print. The more frequent the color change, the more filament and time it means. After finishing my tests with AMS, I continued with printings using filaments like ASA, ABS, PETG, and TPU. This is a box for the printing I got with PETG to fall into the waste of the filament change I just showed. Of course, it may not be sufficient for long-term printing. There are also larger models for that, but it will be extremely sufficient for your standard uses. As for the printing quality, the layer traces are not noticeable at all. I'm not exaggerating, it's quite an industrial production quality print. Of course, since I will photograph very closely, the layers will be visible, but even up close with the naked eye, it is barely noticeable. It's a completely flawless, exceptionally good printing without the slightest ripple or layer trace visible on it whatsoever. This is also one of the best printings I've received. We continue with another functional model I've printed for the printer. One of the best for the printings I've done is this one. We continue with another functional model I've printed for the printer. The model you see was printed in 2 parts with ABS. This model is designed to be positioned next to the printer when we remove the top glass of the X1 carbon. I think it's very sensible and necessary, because when you remove the glass, you don't know where to put it so it doesn't break. Thus, I definitely recommend this model to those buying the printer. Its print quality matches the previous model. There are no layer marks, no printing error. ABS is quickly affected by airflow and requires a constant ambient temperature. I shut down the printer while taking the printing because the pull rate was high, and I also applied adhesive to the build plate. Even though the model has many sharp points and edges, there was no lift. It's a beautiful, successful print from every angle. I got a printing with ASA after ABS. ASA is a material very similar to ABS. However, unlike ABS, it's highly resistant to outdoor conditions. Even when exposed to sunlight for long, it's not affected by ultraviolet light and keeps its structural integrity. This piece is a printing I got for one of my clients. They designed it themselves and it was to be used outdoors. I thought this is a great chance to print with X1 carbon. Though it's a harder material than ABS, I completed the printing without issues. Sagging occurred in the parts where it made a right angle because the fans did not work while printing. I found these reasonable. Apart from that, there is no sagging at the edges. The layers also look very nice, smooth, and impeccable. The next piece was printed with TPU flexible filament. Again, I went through functional parts. These are anti-vibration feet designed for X1 carbon. The designer said it has a beneficial effect on sound as much as vibration. While wondering how useful it could be, I noticed that Bambu was selling the same feet on their site. I said, okay. If its own brand uses this model, it must be work. Of course, the level of flexibility is important. A friend who uses X1 carbon said he got TPU printing at a speed of 120 millimeters s. As someone who has never gone above 50 millimeters per second on TPU, I was surprised, but I said, while I'm printing 4 pieces, let's indeed do a speed test as well. Again, I cautiously increased the speed gradually. The parts were printed at speeds of 50, 75, 100, and 125 millimeters per second. There's almost no difference in surface quality. The only clear difference is the increase in sagging where the model's seam mark is. As you can see, as the speed increases, there has also been an increase in sagging. Other than that, I don't see a problem at other points. Even right angles that protrude outward look clear. While the standard 50 millimeters per second speed is effective, I also found it effective that the printer did not give bad results in its other fast printings. Of course, I stopped when it reached 125 millimeters per second. Likely the printer could have pushed higher speeds since the extruder system is working well. But when the speed increased, both structural distortions began to increase and the extruder will now start to stretch and thin the flexible filament as it pulls the filament slightly. This will result in insufficient filament flow. Gaps will begin to form between the layers and the layers will not have a smooth appearance or there will be stringing. Therefore, I think these speeds are more than enough for TPU. Of course, I used a TPU filament with a hardness of 95A. When a flexible filament with a higher hardness is used, these speeds can be slightly increased. Or on the contrary, if you use a softer TPU, you will need to reduce the speed this time. Anyway, after the TPU speed tests, we've come to the speed tests I did with PLA. What you see is a warrior bust. It consists of 2 parts, the pedestal and the top of the bust, and it has many details that can be evaluated on it. Now let's compare all speeds side by side, noting their differences one by one from the lower base. There are flat and sharp surfaces here. It's very hard to see the differences between them unless you look very closely or with a magnifying glass. Perhaps a slight vibration is noticeable on the straight lines at the bottom. Other than that, there's no difference in print quality either on upper surfaces or the sharpest parts at the top. When we examine the chest and shoulder armors of the body, almost the same situation applies. I couldn't tell which one was printed at 50, which one at 500 millimeter per second if these models were given to me in a mixed order. So I can't really perceive from this point. At least this is true for the patterns on the chest part. There's been slight stringing at speeds of 50 and 150 millimeters per second, decreasing as the speed goes up. It's almost nullified at speeds of 250 and 500 millimeters per second. Effects of speed are more pronounced on the dragon on the warrior's shoulder. There is no vibration effect at 50 millimeters per second. However, at 150, 250, and 500, the vibration effects slightly rise. According to the speed increase, vibration effects are reasonable. Effects also occur on your face but are much less in the front. It's not noticeable in your beard or anything really. The effects are also quite minimal on smooth areas like the nose, cheek, or forehead. When we view the model profile from the side, vibration effects are more pronounced. Naturally, 50 millimeter per second intervals seem best. But I can't really see a noticeable variability between 150, 250, or 500 millimeters per second. The results are quite close. Generally, as speed increases, distortions are seen in thin patterns. This model has thin patterns on its bun, yet there's no texture loss or distortion. The patterns both behind and in front of the bun come out very nice and clear. There is no or very little difference between speeds at many points. Considering efficiency in terms of speed, we can say that the results are very successful and that the X1 Carbon has successfully passed the speed tests. The moment I opened the box, the printer had already excited me, but as I got the prints and saw the results, this excitement increased even more. The more printing I did, the more I wanted to do. One more, wait, let me print this, let me print that, and I ended up doing a lot of printing. Because you can't get enough, you want more as long as the machine doesn't upset you and the results come out nicely. You feel like trying even more. I actually did a speed test for flexible filament for the very first time. A flawless printer? No, it's not. It has minor shortcomings, but it's commendable that it has such superior features and never disappoints the user. BambuLab has shared something akin to what I said on their own website, but in even more beautiful sentences. I also want to show you that post. The beginning of a new era. Do all those smart features completely eliminate tinkering and tuning? No. Is this printer as reliable as a photocopier? No. Is this the printer you guys dream of? Not there yet, but we're truly proud of X1. We're still far from our ultimate goal. But the X1 makes the first step. A very daring leap. We hope the X1 will be a milestone leading to a new era in 3D printing. I completely agree with what they said. Apart from this, I really like the bed leveling, the pressure sensor and LiDAR work very harmoniously. I didn't encounter a problem like the nozzle being too close to the plate or a bit far away even in one of my printings. In every printing I took, the first layer was at the level it should be. The wireless connection feature is quite successful. You have no difficulty connecting from a phone, tablet, or computer. It's nice to be able to adjust the printing settings from here or watch the printing live from the camera. I can't say that the X1 Carbon is a quiet printer when all the fans are running, but I can say it's a bit quieter than similar fast printers I've used before. In the tests I conducted, I got results between 60-62 decibels at a speed of 50 millimeters per second when the fans were on, but when the fans were off, the sound drops to 49-50 decibels. When fans are open at a speed of 300 millimeters per second, the sound is between 60-63 decibels, but when closed, it changes between 56-58 decibels. I tried this as well since we will completely cover the body when using materials like ABS and at the same time the fans will not work. Excluding sudden accelerations, sound ranges from 47-50 decibels at 50 millimeters per second and 50-55 decibels at 300 millimeters per second. AMS has turned out to be a very nice system. As I said, I had some doubts, but it eliminated most of them. One problem was that sometimes the remains of the filament would fall into the printer's inner part during filament change. Aside from that, the system worked quite well. During the filament change, the extruder first carefully cuts the filament and then proceeds to perform the printing. Therefore, your filament always comes out clean from the extruder. This prevents potential problems like clogging. I don't usually talk about printer prices in my reviews, but I must say that the X1 Carbon is an expensive printer. I wish they had more reasonable pricing policies. A friend of mine who saw the printer said it's become the Apple of the 3D printing market. A very accurate observation. It can be compared to Apple in terms of its smoothness, material quality, and pricing policy. However, when you use the X1 Carbon, you understand that this printer is the work of expert and good engineers. They have thought and designed everything in detail. I really enjoyed reviewing it. I hope the same has been true for you. If you also want to get an X1 Carbon, I'm adding the product link to the description section. I am waiting for your comments and questions about the printer in the comment section. May your printer work flawlessly and your printings be perfect. See you in the next video. Goodbye.